Welcome back, IB18. That was great fun. Let's do some more maths. Throughout history, mathematicians have been fascinated with the idea of prime numbers. Prime numbers are numbers which can only be divided by themselves and 1. And mathematicians have asked themselves, are there formulae to generate prime numbers? Let's look at this formula, written as a function. You've all studied functions. Don't try to fool your TOK teacher by saying we don't know functions. You all do. This one is n squared plus n plus 41. Let's try to work out f of 1. We just replace 1 in the function. We get 43. And what we're interested in this investigation is that number odd? Yes, it is. Is it prime? Yes, it is. It doesn't appear in any multiplication table apart from its own and that of 1. Is it a square number? No. Let's have a race. I'll give you 3 minutes. Try to work out as many of the others as you can, and then I'll show you some results. Ready? Go. Oh yeah, pause the video as well. That was fun. Here's the data. These numbers are all odd. And they're all prime. Look at 71. That isn't in any multiplication table apart from its own and 1. None of them are square. Remember, a square number is something like 9 times 9, which is 81. Okay. In the previous investigation, your TOK teacher will have reminded you of inductive reasoning, when we reason from many particular cases to make a general statement. So we might conjecture that it's always an odd number that we get from this function, that it's always a prime number and it's never a square number. If we made these conjectures or hypotheses, they would extend to infinity because numbers come in infinite sets. Well, I was cheating. I made this with a spreadsheet. I didn't work all these out. So let's look at some more data. Same old story. Always odd, always prime, never square. Same old story. Oh, what's happened here? It's still odd, but this is not a prime number and it is a square number. Let's think about this. We can actually prove it's always odd right the way to infinity, because n squared plus n plus 41 is n plus 1 plus 41. Think about it. This format gives us something like, if n was 9, 9 times 10 plus 41. This must be even plus odd is odd. Or if it went the other way, if this was 10 for n plus 1 would be 11 plus 41. This is still an even number, and this is still an odd. We still get an odd number as the answer. So we can prove this with deduction, and that's true to infinity. That's one of the powerful things about maths. You can prove things work. all the way to infinity and beyond. So what's happened here? Well, when n is 40, something special happens. 40 squared plus 40 plus 41 is 40. 40 plus 1 plus 41, which is 40 times 41 plus 41. I've run out of space. That gives us how many 41s? 41 times 41, which is 41 squared. That's a square number, therefore it cannot be prime because it's in the 41 times table. So what we have here is an example of deductive proof to prove the answer is always odd. And then we have another black swan here, which shows the hypothesis that it's always prime is false. And I guess we have another black swan, the hypothesis that it's never squared is also false. Well done.